Consider the points A at 2, 3, minus 1 and B at minus 1, 1, 2. Find the vectors OA and OB. Remember, they're just position vectors of A and B, O being the origin. So how do you get from 0, 0, 0 to A? Well, you just put in the coordinates of A as a vector, and the same with B. Find the cross product OA times OB. Find the magnitude of the cross product OA cross OB, and then explain why the area of the triangle OAB is a half of the magnitude of the cross product of OA and OB. So, part A, part 1, OA, as I was saying, is just the position vector of A, so that is 2, 3, minus 1. And OB is just the position vector of B. So that is minus 1, 1, 2. Okay, part 2. So OA cross OB, that is going to be IJK 2, 3, minus 1, minus 1, 1, 2. The determinant of that. So that equals I times the determinant of 3 minus 1, 1, 2, minus j, always minus j, 2 minus 1, minus 1, 2, plus k times the determinant of 2, 3, minus 1, 1. Okay, so that equals I times 3 times 2 minus 1 times 1 minus j times 2 times 2 minus 1 times minus 1, so I might actually just put 1 in there, plus k times 2 times 1 is 2, minus 3 times minus 1 is minus 3. Right, so that is going to be I times 6 minus 1, so plus 1, minus j times 4 minus 1, which is 3, plus k times 2 minus 3 is 5. So the cross product OA cross OB equals 7i minus 3j plus 5k. So 7 minus 3, 5. Right, we now need to find the magnitude of that. So the magnitude of OA times OB, say times, I mean cross. Remember, vectors, as in multiplying vectors, that's an ambiguous term. There's a dot product, a scalar product, and there's a cross product, a vector product. You don't multiply vectors as such. So OA cross B, the magnitude of that is going to be the square root of 7 squared plus 3 squared plus 5 squared. That is the square root of 49 plus 9 plus 25. 49 plus 9 is 58, so 68, 78 plus the 5 is 83, so root 83. Okay, we now move on to part B, and it says explain why the area of triangle OAB is a half of the magnitude of the cross product. So you will know soon, or you should know soon from experience, that the cross product, if you interpret that geometrically, it is the area of a parallelogram formed if you started both of these vectors from the same place. So they do start from the same place here, so both start from O. So if we then drew a parallelogram, that would be the area of the parallelogram. So the area, the cross product, basically what I'm trying to get at is this is a standard result. So half of the magnitude of the cross product of two vectors will give you the area of the triangle formed if they both started from the same point. But to explain that, we're just going to draw a little diagram. So if we've got O, can be here, they both start from O, so this can be A. A can be over there, and there's B. Right, and so we're interested in this triangle, and you have theta here, right? So the length of this line must be the magnitude of OA. That's the magnitude means length. The length of this line must be the magnitude of OB. And you should know from just basic triangle, non-right angled trigonometry that area equals a half times the side times another side times the sine of the angle between them. So half times the magnitude of OA times the magnitude of OB times sine of the angle between them. And if you look at that, all of this, apart from the half, is actually the magnitude of the cross product. Cross OB. So that is the magnitude of, in this case, OA cross OB, but in a more general case, the two vectors that you find in the cross product are. Okay? So that shows us that area of triangle equals a half times the magnitude of OA cross OB. And remember, that is a general result. If you half the magnitude of the cross products of two vectors, it will always find the area of the triangle that they span. And if you don't half it, it would be a parallelogram. So what I mean by that, if we drew B again, and we drew A again, and we had to a point here, the area of this whole parallelogram would be the magnitude of OA cross OB. That would be the area of the whole parallelogram, and if we half it, that gives you the triangle.